Okay, so this is going to be our last set of functional groups, and these are going to include carbonyls and their derivatives. Okay, so just like in the last couple of videos, again, I highly recommend you pause, record all this information, create your own table so that you're able to go back to this and use these as your notes. Okay, so let's run through each of our structures. We'll start with the aldehydes and ketones first. For both of them, their functional group is the same. It's a carbonyl. It's where this carbonyl is placed that is going to make it either an aldehyde or a ketone. For an aldehyde, that carbon double bonded oxygen needs to be a terminal. So it's going to be a terminal carbonyl. That is what is going to make it an aldehyde, whereas a ketone, it is going to be an internal carbonyl. And I'll show you some examples in the next few slides. Okay, so carbonyls are our first functional group, and our two organic families are either an aldehyde, terminal carbonyl, or a ketone, internal carbonyl. Our next functional group name is a carboxyl. This is going to be a carboxylic acid. Now, a carboxyl is a combination of a carbonyl and a hydroxyl. So carbonyl, we know this is a carbon double bonded oxygen, and our hydroxyl, we know, is an OH group. Combined, this molecular type or organic family is a carboxylic acid, and again, this is going to have to be a terminal carbonyl, but in addition to that, it has to have that OH group. Okay, next down the list, we have our esters. That's our organic family or molecule type. This is going to be an acyl. This is going to be a combination of a carbonyl and an alkoxy. So we've already talked about that carbonyl, right, is this carbon double bonded oxygen. We use a different color for our alkoxy. And we know that our alkoxy is an oxygen that is sandwiched between two R groups. So put those together and you've got your ester. So we'll be talking in quite a bit of detail later in the semester about these esters and the reactions to create them. But essentially what you're doing is removing a hydrogen from a let me try that again. You are removing a hydrogen from a hydroxyl group and replacing that with an R group. Again, this is going to be something that is internal. Our very last functional group and organic family would be an amide, and we'll talk about what these numbers mean: primary, secondary, tertiary. We'll talk about those a little bit later on in the semester. But essentially what you have here, again, is an acyl. Instead of having a carbonyl and an alkoxy, you have a carbonyl and an amine. So again, we know that our carbonyl is that carbon double bonded oxygen, and we just talked about amines, and so amine is a nitrogen group. Very similar to an ester, what you have here is a a hydrogen removed from a hydroxyl group and replaced by an amine or nitrogen. Okay. Next slide, I'm going to be showing you some ball and stick models, just like I did in the last video. Okay, so here we have an example of a carbonyl functional group as an aldehyde. So notice here, and this is super important, that carbonyl is on a terminal atom, which means that you have only one R group on that carbonyl functional group. The other atom on that functional group will be a hydrogen. Okay, so again, it has to be at the end of an atom and it has to be terminal. This R group can be massive. many carbons long. In this case, I've only chosen one. But again, I've got my double bonded carbon oxygen, and again, it's terminal. The other atom here is a hydrogen. Okay, so next we have our ketone. Again, still same functional group, right? Still a carbonyl. Here's my carbonyl right here. Only this time, instead of being on a terminal carbon, it is on an internal carbon. So I have two R groups on either side of that functional group, on either side of that carbonyl. And so you can see that right here in this guy, I've got my two R groups here, and then I've got my carbon double bonded oxygen right here on that internal carbon. All right, so next we have our carboxyl. This is a combination of a carbonyl and a hydroxyl, carboxyl. And this is a carboxylic acid. And we will spend a bit of time talking about these. It's called a carboxylic acid because it does behave as an acid. So again, I've got this carbonyl group here, and I have my hydroxyl group here. This combination is what creates or gives it the family of being a carboxylic acid. And again, I've got that attached to some R group. This absolutely has to be terminal. You cannot have a hydroxyl group as an interior functional group. Okay, so here I have my carboxyl, here I've got my hydroxyl. So this is an example of that carboxylic acid. All right, next we have our first carboxyl derivative, our ester. And so what we have here is we have our carbonyl plus our alkoxy. So right here, I have my carbonyl group, and right here, I have my alkoxy. So remember, for an alkoxy, it is going to be a sandwiched oxygen between two carbons. And so that is this oxygen right here, or this oxygen here. And then important to note that that carbonyl has to be directly next to that alkoxy. So this is my ester. Again, got that carbonyl and that alkoxy right next to each other. All right, and lastly, we have our last carboxyl derivative, and this is our amide. So our acyl carboxyl derivative, our amide. And here we have a carbonyl plus an amide, plus an amine. That gives us our amide. So again, that carbon double bonded oxygen, there is our carbonyl, and our amine is this nitrogen group here. Again, I've got my two R groups on either side. This is going to be an interior functional group. So I've got my double bonded oxygen, my carbonyl here, and my amine here. And again, I've got my two R groups